Okay, math analysis. This is first part of two videos on the Chapter 8 and 9 review worksheet. I'm going to go over problems 6, 8, 9, 10, and 11. These all deal with the Chapter 8 stuff. 6 and 8 should go pretty fast, and 9, 10, and 11 are a little more difficult. First thing, number 6 here, inverse cosine. Remember, first thing, there's no equal sign on this problem. We're not solving an equation for x. We're simply finding the value of this, the numeric value of this. So there's only one answer on this, so we don't have to think that, oh, we get an answer and then we plus or minus it, or we add 2n pi or any of that stuff. All we're doing is finding what the inverse cosine of negative root 3 over 2 is. Before you even look at the number, remember, just inverse cosine, we immediately, if I can get a pen to work, there we go. Immediately on an inverse cosine problem, cross out the bottom two quadrants. It is a negative, so cosine is positive there, so we get rid of it. Remember, now it's cosine, so we've got to think what triangle gives us the adjacent, because remember cosine is CAH, adjacent over hypotenuse. What angle gives us the adjacent of root 3 over 2? Well, that is a 30-degree angle. Terrible, but that's a 30-degree angle right there. A 30-degree reference. Because the adjacent is the longer one, the root 3 over 2. And now all I have to do is remember, inverse trig is giving me angles, so the final question is simply, what is that angle of rotation to get there? Well, it's a 30 degrees, so I count by sixes. 1 6, 2 6, 3 6, 4 6, 5 6. So the answer is simply 5 pi over 6. Remember, for an inverse cosine problem, the answer has to be between 0 and pi. And 5 pi over 6 is between 0 and pi, so we're good. Next one I'm going to do is number 8. Got two parts here, but again, first just focus on the stuff in the parentheses, the inverse tan of 1. And again, before we even worry about the number, inverse tan and inverse sine are the same, where we cross out the left side. And now this is a positive 1. It's not going to be on an axis. That's for sine and cosine. For tangent to be 1, to be positive 1, that has to be a 45. And hopefully we're starting to get a little more familiar and a little more comfortable with that, because the opposite and the adjacent on a 45 are the same, so they would equal 1. And then I just say, okay, what is that angle of rotation in radians? Well, it's just positive pi over 4. So now I've solved that part, but now I'm doing the regular cosine of pi over 4. And again, this is what we've done for quite a while now. Well, I've already got the triangle drawn. That's convenient. Now I'm just saying, what is the adjacent length? Because remember, regular trig gets you lengths, like 1, 1/2, root 3 over 2, that kind of stuff. So it's saying, what is the adjacent on a 45? Well, the adjacent and the opposite are the same, but it is root 2 over 2. That's my final answer. Remember, inverse trig, angles are your answers, just like on the previous one. Inverse trig, angles are your answer. Regular trig, side lengths. Or maybe it's a 1 or a 0, you know, if it's on an axis or something, it could be a 1 or a 0. But same logic. Okay, number 9, 10, 11 start to get a little trickier. And there will be ones like these on the test, so that's definitely why they're on the review. Find all solutions to cosine of 2x plus root 3 over 2 equals 0. And it doesn't give me an interval, it just says find all solutions. So this one, notice again, there's an equal sign here, and there's a variable I'm solving for. I'm finding all solutions. So this one's going to have the whole plus 2n pi, and then maybe I have to do some more work afterwards. One thing is, this kind of problem we did before we figured out the double angle identity for cosine. If you tried it, don't do this, but if you tried it, the double angle identity for cosine breaks into cos squared minus sin squared, and then you'd still have plus root 3 over 2 equals 0. Maybe you could substitute in this with 1 minus sin squared using a Pythagorean identity. Again, none of this is going to work on this. I just wanted you to see where it goes to. So I could substitute that in with a equivalent expression, and I'd have negative 2 sine squared. I'd have 1 plus that, so if I get common denominators, that would be plus 2 plus root 3 all over 2. Okay, you can see that this is getting really nasty. And at this point, we're not going to know what to do with this. The numbers are just getting too ugly. So this is not where we want to use the double angle identity. So let me get rid of that. What we want to do on this was before. Remember, this is where that 2x is scary to us. So let's replace it with something nice and easy, like the letter U. That's much more comfortable. So now I just solve it like a normal equation. So what I would do first is I would minus this over. So at this point I have the cosine of U equals negative root 3 over 2. This is the stuff you want to be writing. Now how do I reverse cosine? Well, I do the inverse cosine. And again, technically what you're doing, you don't have to write this, but you're doing the inverse cosine of the cosine. You're doing the inverse cosine of that. Just whatever you do to one side, you do the other. That pretty much goes away, and you're left with U equals the inverse cosine of negative root 3 over 2. Alright, inverse cosine. Immediately cross out the bottom. This is actually the same one we already did, but it's negative. Cross out the right. What angle gives you an adjacent, because it's a cosine? That again is the 30 degree. So again, I asked myself, what is that angle in radians? Again, we did this on number 6 a couple problems ago. That is 5 pi over 6. So again, that right there is 5 pi over 6, right there. So, and now we talked about this, since I'm solving an equation, we found a little rule that, or we discovered a rule that's basically said when you're doing a cosine problem and you get an answer, to account for the other answer, you just do really, it's plus or minus. Plus 2 n pi or 2 k pi, doesn't matter, it's just some variable. But now again, remember what we just solved for. In all this, we solved for the letter U. But in the beginning, U was, erase that, U was actually 2x. So I have to now go, oh wait, I didn't solve for x yet. Put this back, there we go. I solved for 2x. Oh, where'd my red go? There we go. So 2x is equivalent to that. How do I get x by itself? Well, now just divide everything by 2. So this would really be multiplying by a half, so dividing by 2 is the same thing as multiplying by 1 over 2. So this part becomes plus or minus 5 pi over 12. Now remember, you do have to divide this. The 2's cancel, it's just plus k pi. That will be a big deal. Some of you on the quiz missed this problem that was similar to this simply because you forgot that you have to divide that as well. That's what x equals. And remember the logic behind this. From a few chapters ago, we said, oh, if we get that, to figure out the period of this function, we would take 2 pi and divide by that. Divide by 2. Gives us a period of pi, meaning it repeats every pi. It repeats every pi. So those are my actual solutions. So kind of if this is a multiple choice, hint, hint, and you see that's got a 2x on it, immediately you're going to know that it's not going to be 2k pi. It's going to be k pi. Okay, a couple more on this first part of the videos. Find all solutions to this. This is number 10, and now we're given a specific interval. Basically, this just means I don't have to worry about doing that whole plus or minus plus 2k pi or find an answer and then do pi minus that answer, any of that mess. Just go around the unit circle at the end and find all the places where it works. It says on your homework on the worksheet that we need to use the Pythagorean identity first. We're going to convert this, and the logic behind this is we have a sine and a cosine in the same equation. That's like having an x and a y in the same equation. It messes it up where it has too many infinite solutions, really. So we're going to substitute for cosine squared. And how are we going to do that? Well, the parent Pythagorean, remember, is sine squared plus cosine squared equals 1. We want to replace cosine squared. So this is our little culprit that's messing everything up. So what I can do is just solve, I can solve for cosine squared here, so I can then substitute it in. Just like you would do in like a chemistry problem or a physics problem when you've given the formula, but you have to move it around to solve for what you want. So I would just minus off sine squared, So now I have that cosine squared is actually equal to 1 minus sine squared. Now I can substitute that for cosine squared. They're equivalent. That'll be very similar to what it is on the test. I don't remember if it's a sine squared or a cosine squared, but there's going to be something you'll want to substitute in for. Okay, so now I can rewrite the equation. Sine x plus 2 equals 2, and now again I'm substituting in 1 minus sine squared. I'll go ahead and add the x line. Okay, so now at least I'm not comparing, apples to oranges. I've got apples to apples. Only signs are in here, so only one variable called sine is in here. So now over here, if I distribute, I have on this side 2 minus 2 sine squared of x. Nothing changed over on the left side. I've got a 2 on both sides on this, so that's convenient. If I minus 2 off, these are really gone. I'm going to go ahead and move this over here to make it positive. So if I add 2 sine squared of x over, add 2 sine squared of x. Again, I'm going baby step by baby step. You obviously wouldn't have to show this. The equation now becomes 2 sine squared x. I still have this here, so plus sine x. Nothing's left over here since I added that over, equals 0. Now it looks much more familiar. I can factor a sine out of both of these terms. There's a sine in that, there's a sine in that. So if I factor out a sine, what's left here? Well, that's a 2, and there's still a sine left. Plus, well, if I factor out sine from that, I just have 1. Now, hopefully these are starting to look familiar. This is looking like problems we've done several times. Now I have to ask myself, what would sine have to equal for this all to 0 out? Well, for this one, sine would just have to equal 0. And then we'll deal with that in a second. What would this sine have to equal? This sine would have to equal negative 1/2. Now we're just about done. We just have to find what are the angles between 0 and 2 pi where sine equals 0 or where sine equals negative 1/2. So this is where we, let's see if I can get on there. There we go. This is where in class we drew ourselves a coordinate plane and we said, all right, it's between 0 and 2 pi, so any solutions around here, don't worry about crossing stuff out. Just go around and see where it happens. Where does sine equal 0? Well, that actually happens right here, because those are the coordinates 1, 0, cos sine. So I call that 0 radians. I know that's confusing. 0 the number or 0 the radian measure? Well, it's 0 the radian measure because we're figuring out what the angle is. The other place where sine equals 0 is right here at negative 1, 0. Again, cos sine. That one is a rotation of pi radians. And again, I'm not going to include 2 pi, even though, yes, that does land right back there, because, and only because, oh, no, wait. Oh, no, we shouldn't be including it. On your directions, that does have a parenthesis on there, not a bracket. I messed that up. So it's a parenthesis. That's why we're not including 2 pi. So those are my solutions that solve this part. Then I say, all right, where does sine equal negative a half? Well, first thing, where's sine negative? Sine is negative down in these two. So I know no solutions will be up here because all students take calculus. Here's where sine's negative. And I'm just saying what angle gives me the opposite of 1/2. A 30 degree in that quadrant, or a 30 degree in that quadrant. So now what is that angle in radians? That is 7 pi over 6. And then what is that rotation? 11 pi over 6. And there you go. There's all your answers. Turns out there are 4 of them. 0, pi, 7 pi over 6, 11 pi over 6. So again, let me recap real fast on that one. What did we do? First we were comparing apples to oranges. So we said, all right, let's convert cosine squared to something that involves sines. That just took manipulating the Pythagorean identity. I substitute in 1 minus sine squared. Did a little distributing, brought everything to the same side. Right here, I said, okay, I've got, oops, that's an arrow. Right here, I've got a factor. So I factor out a sine, and then this is what we've done bunches of times. So really, the main hitch there on that one is realizing that you need to get that in terms of sines instead. Okay, one more on this video. There is one on the test that's like this. Find all solutions of tangent squared minus 3 equals 0. I'm not going to convert into sines or cosines or anything, and you'll see why in just a second. I'm just going to add the 3 over. So I only have one variable called tangent on this, so I don't have to do any kind of converting or replacing. So really, tan squared equals 3. Looks kind of bizarre. Here's where the hitch comes in. How do I get tan by itself? Well, I square root. Now you got to be careful on this. When I square root, I get tan x equals plus or minus root 3, not just root 3. Because remember, when I'm solving an equation and I square root, yeah, there's that plus and minus. Now it's basically asking me, where in the first spin around the unit circle does the tangent equal root 3? Well, that actually is one of our regular angles. And it turns out that, well, it's a root 3, so we're thinking it's got to be the 30 or the 60 is my reference. So we got a root 3 in there. Okay, well, which one is it? Is it from the 60 that the opposite over adjacent equals root 3, or is it from the 30 that the opposite over adjacent equals root 3? Turns out it is from the 60. Again, if I did opposite, root 3 over 2, over adjacent, that would mean times by 2 over 1. Hey, there it is, root 3, which is what we wanted. So 60 degrees is my reference. Now, the fact that it says plus or minus, and this will happen on the test, simply means that it doesn't really matter what quadrant I'm in, because if it's positive, hey, or if it's negative, there. So basically, every 60 degree reference going around the unit circle. So 60 degree reference there. 60 degree reference there. 60 degree reference there. 60 degree reference there. What are all those angles? Well, that is pi over 3. Again, I assume at this point we can count that out. That's 2 pi over 3. That is 4 pi over 3. And finally, 5 pi over 3. So again, I just solved it like it's a normal equation. Think of it as if I had x squared minus 3 equals 0. I'd add 3. I'd square root, but remember when you square root, you get plus or minus. But I really wasn't doing x, I was doing tan x. And then from there, it was just use the trig part. And I got 4 answers. 4 angles in the normal first spin that make that true. Okay, I'm going to do one more video of some of the Chapter 9 stuff, but I think this was the most difficult stuff from the front of the Chapter 8 and 9 review.